All right. What's interesting is we've been very careful in building this whole procedure up. We developed limits with our limit properties. Those were all based upon the epsilon delta definition. Then we went ahead and gave the derivative as a particular type of limit. Okay, folks, are derivatives and limits separate? No. The derivative is a special type of limit. Okay? We've worked with those individually, but now we've got some generalized rules. All of a sudden, things are going to start snowballing here. Okay? We can do these procedures much faster now. So let's take the derivative of this function. Okay? The big picture is this function is the sum of several terms, right? So I can take the derivatives term-wise. That means that when I want to take the derivative of f, I can just look at each term independently and take its derivative. Well, this is a constant multiple times a power function. I can take the derivative of a power function, and the constant multiple rule says the constant just comes along for the ride. So this is going to be minus 24 x to the 7th. True? Plus 14 x to the 6th. Plus 4. Why? The derivative of a linear function is just its slope, right? How does a line change? It changes based upon its slope. I'm going to add to this plus 0. What is that plus 0 there for? The derivative of which term? Yeah, this negative 2 term, which is what with regards to x? What is negative 2 with regards to x? It's constant, right? That term doesn't change as x changes. What's the derivative of a constant? 0. Folks, do you have to write that plus 0? No, I might write it a few times in these early stages just so you get used to the idea. Okay? All right, I'd like you to do the rest of these problems. All right, folks, I don't want you going too far with a couple of these. I've got a couple mean questions in here. Okay, what's the big picture for function y here? It's a what of two things? Folks, what's the big picture of function y here? It's a what of two things? What's the big operation between these two expressions? It's a product. Can you take the derivative of a function factor-wise? No, we said derivatives don't distribute over products. Well, what do we do? Well, what does distribute over over things? Multiplication does. So, I've been picking on you for labeling things. Maybe you think I've been excessive about it. But now it's very important. I am not going to take the derivative in this next step. In the next step, I'm just going to take the function y and rewrite it. What do I get? I get x to the 5th minus 3x cubed plus, is that a 1? I can't read that.
That's 1.
That's a 1? So plus x squared. What did I do there, folks? All I did was rewrite the function. How do you know I didn't take the derivative? Everyone hear what Jigme said? It's still y. How do I know it's still y? Because I've labeled it. Right? Does labeling matter? Yes. All right, so now we're ready to take the derivative. Let me just say this, just to make sure everyone's clear with this. I rewrote the product of things as a sum of terms. So we had a product of factors, and now we have a sum of terms. And I can take derivatives term-wise. Okay, so we get that y prime is equal to 5x to the 4th minus 9x squared plus 2x. Folks, when did I take the derivative? Between this step and this step. How do you know? Because I labeled it. Okay. So come on, it doesn't cost that much to put a y in front of something. It doesn't cost that much to put a y prime in front of something. If I ask you for a derivative, folks, on a test, on this next exam, if I say give me the derivative and you say it's this, I'm going to mark you wrong by 1 point. Yeah, I'll dock a point for that because you're not labeling it, and I don't know that you're being as careful as you should be. That's mean. It's all right. I'm not here to make friends. If you still want to be friends, that'd be nice, but I'm not here to make them. Sage.
I have a question. Can I put dy
dy over.
Yes, you can so you can always interchange between Leibniz's and prime notation as you wish.
I put it in front of the x to the fifth minus 3x cubed. Where it's like dy dx.
Let's talk about that later.
Cool.
Sometimes when I don't want to take a derivative all the way at once, I might use that derivative operator in places, and I'll show you some of that. But I want to hold off on doing that for a minute. Okay. Yeah. All right, folks, let's look at letter C here. This doesn't look like my power rule. That's the only rule I've learned so far. Yeah. Jenny says, hey, wait a minute. Can't you rewrite this function like you did the last one? I think so. I could rewrite this as 4t to the what power? 4t to the what, folks? Oh, folks. 4t to the... I'm just not hearing enough people saying it. Right? All we did was rewrite the function. How do you know I just rewrote the function?
Because you labeled it.
I labeled it. Let's use Leibniz notation, ds dt is equal to 12t to the, whoa, watch your fingers in the saw blades. 4t to the what? Subtract 1 from the exponent. Right? What's negative 3 minus 1? I know you know this, but you're just a little confused. Yeah. I know you got this, folks. It's just watch out. There's some places where you can step in it. Maybe you do the first few times, and then you get it clarified. Okay? Now, folks, I think it's polite to return something the way it was given to you. This function had no negative exponents in it, right? So why would we return it with negative exponents? That's kind of rude. Okay? So let's go ahead and rewrite it as 12 over t to the fourth. Okay? My math lab will always want you to simplify those. Okay? On my exams, I will say simplify on problems where I want you to simplify, and on problems where I don't care, I'll write do not simplify. Meaning I'm only interested in the derivative step and not the simplification step. But as a rule of thumb, you should return things the way they were given. If you didn't have negative exponents to begin with, then you shouldn't return it with negative exponents. Okay? All right, let's look at letter D here. What is the derivative of this function? Two pi r. How we doing, folks? Hey, if this were if calculus were a TV series with three seasons in it, we're in season 1, right? We've got our own plot issues to deal with in season 1. But if you want folks showing up later, you got to drop some nibbles about what's coming up. Okay? What function is this right here? What function does this describe? The area of a circle, right? What's its derivative? Circumference of a circle. I'm oversimplifying something there by quite a lot. Okay, but this is something that's going to happen in the final season of calculus. Okay? This is a plot point that's going to be important in the final season of calculus. Okay? There's some sort of relationship between an area and a boundary. An area and a circumference, or an area and a perimeter. Okay? That's coming up in Calc 3. All right, that's an oversimplification, by the way. All right, everyone do letter E as quick as you can. Keep your answers to yourself. Do E as quick as you can. Right? What's the variable of this function? Well, there is a variable. What is it understood to be? X. Where does it show up in the expression of the function? It doesn't. So what is it? It's constant with regards to the variable x. What's the derivative of a constant? 0. Folks, be careful. You'll step in it. I know you will at some point. It's easy to do, but watch out. Okay? I've given you a pretty powerful hammer here, but not everything is a nail. All right. I'd like to do letter Y now. I'm going to rewrite it as the square root of x over the square root of x minus x cubed over the square root of x. Everyone see what I did there, folks? All right, don't raise your hand just yet. Think for a minute. Could I have canceled those two square roots of x's just as they sat right there? No, you can't. If I have a plus b over a, is that the same thing as b? If I do 5 plus 2 over 5, is that the same thing as 2? Heck no. One's 7/5, one's 2. Right? So can I cancel those b's? Or can I cancel those a's? No. So can I cancel these square roots? No. I know everybody in here knows this. I know you all know this. But for some reason, when you see that same expression in a foreign environment, you forget it. Okay? Be careful. If you make mistakes canceling, you need to come see me. Okay? You know whether you got some wrong on your test for making mistakes canceling. Okay? All right. So this gives me y is equal to 1 minus x to the 5/2. What on earth? So we had y is equal to 1 plus x to the 3rd over the square root of x, right? Okay, let's clean that up a little bit. That's y equals 1 plus x to the 3rd over, how could I rewrite a radical? I could write it as a fractional exponent, right? So it's x to what power? X to the 1/2 power, right, folks? How do you divide by exponents of like bases? You subtract their powers. That gives us y is equal to 1 plus, how do I go ahead and write the number 3 so I can combine it with the fraction 1/2? I write it as 6/2, right? Minus 1/2. How do you combine fractions through addition and subtraction? You combine their numerators. What does that leave me with? X to the 5/2. Okay, folks, if you struggle with that, you need to do some practicing of your properties of exponents. Okay? I am more than happy to help you with that. Okay? But you got to get it fixed as soon as possible. Okay? Cameron?
Why did the subtraction become? It was 1 minus cubed over square root of x.
Oh, I apologize. I was just trying to copy it over from the previous page. Thank you. Great question. Those should all be minus signs. All of this was just, thank you, that's dead wrong. All of this was justification, though, with how I ended up with this, except for that. Sorry. Thank you. Thanks, Karen. Good eye. Yoshin.
We keep the 1.
Well, I haven't taken the derivative yet, right?
Oh.
How do you know that? Because this is still y. Sage.
Can I write x to the 2.5 power? Is that legal?
I mean, it's rude.
It's rude, but is it legal?
Yeah,
Okay, cool.
but it's rude. Okay, now let's take the derivative. Hey, what's the derivative of this constant term, folks? 0. I'll go ahead and write the 0. Do you have to write the 0? No. Okay, but I'll do it for a few more times. Okay. How do I take the derivative of a power function? I apply the power rule, which says do what? Folks, how do I subtract 1 from 5/2? I subtract 2/2 from 5/2, which leaves me with the remaining 3/2.
Wait, can you explain that one?
Yeah, definitely. So if we have x to the 5/2 minus 1, I'm just doing that term. X to the 5, I'm just looking at just this piece. This is the same thing as x to the 5/2 minus 2/2, right? Because that's just another, I'm getting a common denominator. But then that's the same thing as, how do you subtract fractions? You subtract their numerators. X to the 3/2.
Why did you subtract 1?
Well, that's what we've been doing, right? When I give you f of x is equal to x to the 7th, what's its derivative? It's 7x to the what? 7 minus 1, right? Subtracting 1 from that exponent. Great question. How we doing, folks?